So to ensure that what we do in the transmission chain, we are going to have several stages. So initially have in phase and quadrature phase, multiply by LO, add it, then you have a pre-amplifier, then you have an actual power amplifier, and then the output is going to be transmitted. So largest voltage thing occurs at the output of the PA. So we don't burden our PA, we have a PAP driver, pre-driver, which is going to ensure that the output is approachable till your 1 dB compression point. So this pre-driver will reduce the load of the actual power amplifier. To ensure that we maximize the gain of our amplifier and minimize the output swing of P-driver, stages preceding it. So we don't place the burden on the power amplifier, we place the burden on the pre-driver. So you can have any number of pre-drivers, and final one should have only one power amplifier which can effectively amplify the signal in a larger extent possible. So next issue what we have is oscillator pulling. So all these issues we have seen in receiver, same thing we are seeing in transmitter because the logic is going to be same. So this issue becomes critical in direct conversion techniques where there is a chance that the oscillator voltage may get transmitted to different parts of system because of your fabrication methodology. So oscillator output voltage can couple with the various parts of system, maybe through the substrate or the parasitic capacitance or the printed circuit board. So appreciable fraction of our amplifier output will couple to the local oscillator. So this is just like coupling between PA and LO. So it will have a huge impact on the spectrum of your receiver, the transmitter. So when does oscillator pulling becomes significant? One is how much LO is producing voltage and current, whether they are high enough to be coupled. What is the Q of the tank circuit used into oscillator? Whether the PA output is differential. Differential na, whether you are going to take the output across the collectors of two transistors or between collector and ground of one transistor. Single-ended na, between collector of Q1 and ground, differential na across collector of Q1 and Q2. Whether you are having feedback loop to overcome pulling, and what is the symmetry of the layout. So all these methodologies, all these questions, if you answer, you can clearly say whether oscillator pulling is present in your circuit or not. So injection pulling will become serious if the power amplifier output exceeds 0 dBm. See, dBm is the power level with respect to 1 milliwatt. 1 milliwatt is going to be 0 dBm. So if the power output PA amplifier exceeds 0 dBm, then the injection pulling may become serious. So how to avoid injection pulling? We have to be ensured that the operating frequency of PA and LO are far away, but which is not possible because they will be always very close. So this issues in the transmitter has given rise to a lot of transmitting architectures, and also noise in the receiver band. So some standards specify the minimum noise transmitter can transmit in the receiver band. So what is the minimum so that receiver will not be overburdened. So in direct conversion receiver, this create a significant noise. So to resolve this issue, we are going to go for offset PLL transmitters. So we are slowly seeing what all the possible issues we have and what solution we have in the transmitter end. So we'll take a break and we'll again assemble by in another 7.5 and we'll continue with the different transmitter architectures.
Okay, sir.